Hi, welcome to the channel Coders Arc, where we unravel the world of coding and architecture. And today I'm going to be covering a simple topic in the AI and ML known as linear regression. I will cover both the simple linear regression and multiple linear regression. You don't really have to understand the math behind it, but I've still tried to capture it. My goal is to make you visually understand what the concept of simple and multiple linear regression is, and I have done that using the 2-dimensional and 3-dimensional visualizations. Hopefully you'll be able to understand the concept. I have also tried to show you what kind of Python libraries are needed that make these computations simpler. So with that said, let's get started. So let's take a quick look at what linear regression is. Linear regression is a fundamental statistical and machine learning technique used to model the relationship between a dependent variable and one or more independent variables. So let's try to understand the concept of simple linear regression visually. What you're seeing are a bunch of points. On the y-axis, you will see the target variable, which in our case is the house price, which means we are trying to predict the house price. And on the x-axis, we have the feature variable, which means the number of rooms. How do the increasing number of rooms affect the house price? So on the x-axis and y-axis, we define our variables. And then the goal is to find a line that will best fit through these points to minimize the loss function. And what I mean by that is it this black line, or is it the red line, or is it the blue line, or is it the green line, or is it the purple line? Which of these lines is the best fit? So we'll have to do some mathematical computations to find the line that best fits through these points. The way you calculate the best fit line is by running a line through these points and calculating the distance of the points from this line, and then calculating the squares. So essentially you have to square up the distance, because some distances could be negative depending on they are above the line or below the line. That's why you have to sum up the squares and then calculate the sum of all those squares and average them out by dividing by the number of points. So now you might be wondering, what if I have at least 1,000 lines that could potentially be a best fit running through these points? Do I have to do the mathematics for every single one of them? And fortunately, no, we don't have to do that math. Luckily, there are many libraries in Python that help you accomplish those tasks, and we will cover them in the next section. So now I want to summarize this simple linear regression before we move on to the multiple linear regression. Essentially, we've covered the concept of dependent variable, which means the outcome or the variable that you want to predict. In our case, it was the price of the house. Then we have the independent variable or the feature variables, which is on the x-axis. These are the predictors or factors that you assume will have an impact on the dependent variable. Linear relationship. Linear regression assumes a linear relationship between the dependent and independent variables. Whether that is true or not in real world, for right now we don't really care about that, but this means that the change in dependent variable is expected to be a linear function of the independent variable. In representing this in the mathematical equation is y, which is the dependent variable, equals to beta o plus beta 1 x plus some error variable, and y is the dependent variable, x is the independent variable, beta o is the y-intercept, which is the value of y when the x variable is 0, beta 1 is the slope of the line, which is the change in y for 1 unit change in x, and error term is the difference between the observed values and the values predicted by the model. Furthermore, how simple linear regression works is, remember I showed you a line which had the sum of squares from the various points. So, and we also talked about, do I have to run multiple lines and calculate the sum of squares of all those lines? And the answer is no, because some smart mathematicians before us have already calculated the formulas that will help us compute that line, that perfect line. And the formulas to compute the beta 1 slope and the beta o intercept is as following, as you can see in this diagram. And where x bar is the mean and y bar is the mean of the independent and the dependent variables respectively. So it's the ordinary least squares method which helps us find the values of beta O and beta 1 that minimize the sum of squared residuals, which is the differences between the observed and predicted values. So at this point, we are ready to move on to the multiple linear regression. One last thing before I move on to the multiple linear regression is that in simple linear regression, Python provides libraries like NumPy, SciPy, and scikit-learn, which really simplify the way in which you calculate the linear regression fit model. So with that said, let's move on to multiple linear regression. I will try to illustrate the concept of multiple linear regression using the two independent variables just so that it's easier for you to visualize this. Because if I start talking about more than two independent variables, it might be difficult to visualize. So I will cover that concept of more than two independent variables after you guys understand the multiple linear regression using the two independent variables. So we have the same problem again. On the y-axis, we have the target variable, which is the house price, which is the value that we are trying to predict. On the x-axis, we have the independent variable, which is the same as the previous example, which we have is the number of rooms. On the z-axis, we have another independent variable now, which is the house age in years. So now we want to use the house age in years and the number of rooms to calculate the y-axis, which is the house price. So the way we do that is very similar to how we do in the simple linear regression. In simple linear regression, we were trying to fit a line through those points in the two dimensions so that it's the best fit line, minimizing the loss. In this example, which is a 3D example, we are trying to fit a plane through these points such that distance is minimal. So is it the yellow plane? Or is it the green plane? Or is it the blue plane? Or is it the dark blue plane or the orange plane? So as you can see, the goal here is to identify the plane out of all the possible planes that can be run through these points that will minimize the loss function. So again, you might be wondering, is it a mathematical calculation that needs to be done? Yes, but there are some smart mathematicians before us who already figured out what that math is, and I will be sharing that shortly. So essentially, multiple linear regression, the model includes several independent variables. Like in our example, it was the number of years of the house age and the number of rooms in the house that could determine the house price. But for more than two independent variables, the equation is y equals beta O plus beta 1 x1 plus beta 2 x2 all the way till beta n xn, where xn represents the nth feature plus the error term. And how it works is, first you have to fit the model, which the process involves finding the values of the coefficients beta O, beta 1 all the way till beta n that minimize the difference between the observed values of dependent variables and those predicted by the model. This is typically done using a method called least squares, which is very similar to what I showed you for the two dimensions, which aims to identify and minimize the sum of squares of the differences, residuals, between observed and predicted values. And the second step is making predictions. Once the model is fitted and the coefficients are determined, you can use that equation to predict the value of dependent variable for given values of independent variables. Third thing is the model evaluation. The model's performance is evaluated using the metrics like R squared, which measures how much of the variability in the dependent variable is explained by the model. Other metrics like adjusted R square, mean squared error, or root mean squared error, which is the RMSE, might also be used. I will not be covering these metrics in this video, and I may cover them in a future video. What are the assumptions? The linear regression assumes linearity, independence, homoscedasticity, constant variance of the errors, and the normal distribution of errors. So important thing is that you will have no correlation between the independent variables. And what I mean by that is the number of rooms in a house are independent of how old a house is. Because if there is a relationship between the the two independent variables, then the multiple linear regression will not work. Also, the application is that it is used in various fields like economics, biology, engineering, and social sciences. And it is suitable for both predictive modeling and inferential statistics. Finally, I want to cover the ordinary least square method for more than one independent variables. As you can see, the goal is to minimize the sigma I equal to 1 all the way till n yi minus xi beta square. So what that means is that the ordinary least square method calculates the coefficients, which is the beta, of the multiple linear regression model by minimizing the sum of the squares of differences between the observed dependent variable and those predicted by the linear model. In mathematical terms, it is represented by this equation, where, and you feel free to take a screenshot of this equation, where yi is the observed value of the dependent variable, xi is the vector of observed values of the independent variables, beta is the vector of coefficients to be estimated. So as you can see, right, we are talking about more than one independent variable, so we have to represent them using the vectors. Finally, what is the calculation process? First, you have the matrix representation. So the problem is often represented in matrix form, making it easier to compute using the linear algebra techniques, because now we are talking about more than one independent variables, more than two independent variables. The equation is capital Y equals capital X beta vector plus E, where capital Y is a vector of the dependent variable, capital X is a matrix of the independent variables, beta is the coefficient vector, and E is the error term. And how do you compute the coefficients? Again, some smart mathematicians before us have already made that determination, where the beta, which is the coefficients vector, equals x transpose times x raised to the power minus 1 multiplied by x transpose and capital Y, where x transpose is the transpose of the matrix X, and x transpose multiplied by x raised to the power minus 1 is the inverse of the matrix XTX. Again, multiple linear regression in Python is accomplished using the NumPy, stats model, and scikit-learn. So as architects and developers, you don't really have to worry about the mathematics, but I just wanted to cover just in case you guys are curious, because it's very important for us to understand the mathematics behind these basic AI models. So hopefully this clears how and what kind of libraries you can use in Python to compute the multiple linear regression best fit model.